Question 8. Two ships leave a port at 9 a.m. One travels at a bearing of north 53 west at 12 knots, and the other at a bearing of south 67 west at 16 knots. This is the picture that we drew from yesterday. The additional question is, how far apart are the ships after 3 hours? Well, the 3 hours is going to help us determine the length of the sides. If the first ship with the blue segment goes at 12 knots, remember 12 knots mean nautical miles. Therefore, if we do 12 times 3, we would get a length of 36. So that ship has traveled 36 nautical miles. The ship in pink that went south 67 west was going a little faster, 16 knots. Therefore, if we do 16 times 3 times, that ship would be a total of 48 miles for its distance. So we can label that segment as well. We're asked to find how far apart the ships are. That means we need the distance from ship to ship. So that's the length we're looking for. We know two of the sides, so to get the third side, we either need to apply law of sines or law of cosines. Well, if we look at the north-south line, together this should equal 180 degrees total. Therefore, if we do 180 minus 53 minus 67, we actually get an angle measure of 60 degrees. That's the angle in between the two sides. This gives us SAS, and anytime we have SAS, we can use law of cosines to solve. Take it from there and get x by itself. Question 9 is a little strange. I think I had 80 and it's supposed to be 70 based on the given angle in the word problem. So remember, by definition, a parallelogram has opposite sides parallel and equal to each other. And we were asked to find the length of the longest diagonal. I defined diagonal for you in a previous worksheet. A diagonal, connects non-adjacent vertices or opposite vertices. So if we were to connect in this direction, that diagonal's across that 70-degree angle. But if we connect it in the other direction, the other angle is actually going to be bigger. So if we go in this direction, this angle right here is 110. Angles that are side by side in a parallelogram, because those sides are parallel, would add up to 180, kind of like when we do our north bearings. So the angle or the segment that we want to find is this segment right here. That will be our x. Now remember, in a parallelogram, if it's 40 on the left, it's also 40 on the right. So just like many of the other problems on this worksheet, we end up with SAS again, which means we can solve this problem with law of cosines. And there you go. Here are the helpful hints for the 8.3 worksheet.